All right, so we have a number properties question here, and it's basically dealing with sign. So is the number positive or negative? We know for a fact that XYZ is greater than 0, meaning it's positive. And that's why I've drawn this chart out on the right. If we look at this, there's a number of ways to make XYZ positive. Either all the numbers are positive. So when you multiply positive, 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 you get a positive number like 2 times 2 times 2, or even make it simpler, right? 1 times 1 times 1 is equal to 1. If we have negative, negative, positive, and all three of these examples are negative, negative, positive, just with a mix in terms of where that sign occurs. If we have -1 times -1 times +1, the two negative signs will cancel out to create a positive, and then we'd have 1 times 1, which equals 1. So as long as we have an even number of negative signs, they will cancel each other out to give a positive number. But if we had, for example, an odd number of negative signs, they would give us a negative number out because the first two would cancel, but then we'd have another negative sign to multiply by, and our number would currently be positive, so that would create a negative. Or if we had negative, positive, positive, a -1 times 1 times 1, we only have one negative sign and there's nothing to cancel it out with, so we'd have a -1 as an answer. So these are the situations we need to be aware of. I've listed out the situations that we could have in terms of solving for our positive XYZ, which we're guaranteed to have. So looking at statement 1, given that we know XYZ is positive, can we tell if X is positive or not? XY is greater than 0. Well, this could be positive, positive, or negative, negative. And if it's positive, positive, then Z would be positive. And if it's negative, negative, then Z would also be positive in order to get an XYZ that was positive. So we know that this is possible with two different situations for X, either X being positive or negative. So it doesn't answer the question of is X positive. This is going to be insufficient. The second statement is the exact same idea. So we have X and Z, and they could be positive, positive, or negative, negative. And then the Y would always be positive in order to make the result of XYZ, that product, positive as a whole. So there are possible situations where we could have X as a positive or a negative number. So this is insufficient as well. Now, when we take the two statements together, the only situation that's consistent across both statements is the positive, positive, positive situation. Because if X is negative, then we need Z and Y to be negative in order for either of these statements to hold true. I'd have to have negative, negative, and I'd have to have negative, negative. But this would break the rule we were given in the statement, in the question stem itself, which is the first piece of information we had, because this would give us a negative number for X, Y, Z. But if we had positive X, we would need positive Z and positive Y to keep these two numbers positive, and that would give us a positive XYZ. So these are the only two situations that we can have given our possibility of having XY and XZ both be positive while keeping the original information also true, which was XYZ was positive. So there's only one situation that fits the bill, and you notice it's this situation here, and that is why our answer choice is C. The two statements independently do not give sufficient answers, but when taken together, they do create a sufficient answer.